Hi, George Diamond here again. Now today we're going to continue our look at solving differential equations by separation of variables. Now these are fairly simple differential equations. They're easily separated. Now in our first video, we looked at just finding the general solution. We practiced separating our variables. We looked at different types of problems. One or two trig problems with some natural log e functions. Now in this video we're going to just look at 4 examples. This is kind of short, but we want to take a look at finding the particular solution of some differential equations. Now the first problem we're going to take a look at is y times y prime minus e to the x equals 0 at the point 0, 4. So y sub 0 equals 4, this is the point 0, 4. Now we've got to be very, very careful with these types of problems because you got to watch out. Okay, at the end, when we get our final solution, now there are there's going to be 2 equations, if you will, 2 answers. Okay, one of them passes through, one of the graphs, if you will, passes through the point 0, 4. Now, this top curve is the one we're talking about. It's the one that passes through the point 0, 4. Okay, now the bottom curve is the other solution, if you will. All right, but now this one passes through the point 0, negative 4. We don't want the bottom curve, we have to get the top curve. So you got to be careful if you see this type of question on the AP Calculus exam, your answer could have plus or minus where you have 2 different solutions. Make sure you pick the right one. Okay, this up here is going to be the positive, so now here's going to be the negative, right? So with this particular problem, we're looking for the one that passes through the point 0, 4. That's going to be the positive solution here. So to get started, now first thing I'm going to do, I'm going to rewrite this instead of y prime, I'm going to write this as dy over dx. Right, now to separate our variables, we did a bunch of these in my first video, so we're just going to continue right on. So basically when it says find a particular solution, okay, we're no longer finding the family of curves, we're finding the one curve. Okay, that's this one right here. We're going to find the equation of this graph right here. Now not the bottom curve. We want the one passing through the point 0, 4. But now we're going to get 2 answers, but we're going to drop one of them. So first thing we got to do is we have to separate our variables. So remember, we're going to get the x's on one side. So the negative, any constants, and the x factor we're going to put on the right-hand side. The y's we're going to leave on the x. So let's move this e to the x over, because it's y dy over dx equals e to the x. Let's multiply dx to both sides. It's the y dy equals e to the x dx. Okay, now we got the one y factor on the left-hand side with the dy. We got e to the x on the right-hand side with the dx. So that problem was really very simple to separate our variables. Right? So most of the problems that we're looking at, it takes a little bit of manipulation, but we are going to be able to separate our variables. As you integrate, though, the antiderivative of y on the left-hand side is y squared over 2. Now the antiderivative of e to the x is e to the x plus c. Right. Now, this is our general solution. So let's multiply everything by 2. So see if I can solve for y squared. So multiply by 2. That gives us y squared equals 2 e to the x plus c. Now, keep in mind, in order to get c, okay, you don't actually have to solve completely for y. So I'm going to go ahead and substitute 4 in for y, 0 in for x right now, and that should give us, we should be able to solve for c. So we're going to end up here with, well, so let's see, what do we get here? So if we're going to substitute 0 in, gives us 4 squared is equal to 2 e to the 0 power plus c. So 16 equals 2 plus c, or c equals 14. So our general solution becomes y squared is equal to 2 e to the x plus 14. Now, if you look at the final solution here now, we're going to take the square root of both sides here. So y equals plus or minus the square root of 2 e to the x plus 14. Now you've got 2 solutions. Now remember, we want the one that passes through the point 0, 14. So the negative, we're going to drop. This should be plus the square root of 2 e to the x plus 14. So you got to watch out. These types of problems, if you're a student taking AP Calculus, you got to be careful that you don't list both solutions if we're looking for the one passing through the point 0, 4. So we want the positive solution. The negative solution will be the one going through the point negative 0, negative 4. Okay, that's a pretty good first problem. Now, next, let me see if I can, brought my game of Monopoly. I'm going to have a little fun later on, play at Monopoly, so let me move this out of the way. And let's continue on with our next problem. All right, so let's erase this. Okay, so that's pretty good. That's a good start. So fairly easy to separate the variables on this problem. So let's try problem number 2. Now this second problem, I'm going to see if I can do this as a multiple choice question. Well, what this is, what you're getting ready to see here, this is actually an old question. It's a question off an old AP Calculus exam that's been released. So let me go ahead and bring it up here for problem number 2. Now keep in mind, if you're taking notes at home, you may need to go ahead and get this problem copied down right now, because I may have to take it off in just a minute if I don't have enough room. But take a look at problem number 2. It says, if dy over dx equals y secant squared x, and y equals 5 when x equals 0, then what does y equal? So what does y equal? All right, so now we've got five answer choices here. So e tangent x plus 4, e tangent x plus 5, 5e tangent x plus 5, or tangent x plus 5x squared. So let's see if we can determine which one of these would be the correct answer choice. Now, so this is problem number 2. Let's write our differential equation. So dy over dx equals, okay, y secant squared x. There we go. Now let's see, we're given y5 when x is 0. I'm going to list this as an ordered pair here. So 0, 5. Okay, and we'll use that point now to get our cost of integration and to get our particular solution to our differential equation. So to get started, we need to separate our variables here. So let's multiply dx to both sides. So we have dy equals y secant squared x dx. All right, so we'll try some little trig problem. Now to separate our variables now, so we got to get rid of this y factor on the right-hand side. So we're going to divide both sides by y. Divide this side by y, give you 1 over y dy equals secant squared x dx now. Okay. Now, that separated our variables. Wasn't so bad. We just have to divide both sides by y here. Now, we're going to integrate the left-hand side and the right-hand side. Now, the antiderivative 1 over y is natural log absolute value y equals, and the antiderivative secant squared is tangent x. So we have tangent x plus c on the right-hand side of our equal sign. Now, if you remember from our last video, to get y out of this natural log, we're going to raise both sides to base e. E natural log absolute value y equals e tangent x plus our constant integration, and that becomes ce tangent x. Okay, here we have y equals, so we can drop the absolute value off the y, so y equals ce to tangent x. Now, what we have here, this is the general solution, all right? This is the equation for the family of curves. Now, we want we need to find c. We want to find the one solution, the one curve that passes through the point 0, 5. So we need to do some substituting in. And let's see what we get. So substitute 5 in for y. Let's substitute 0 in for x. And that gives us 5 is equal to ce to the tangent 0. Now tangent 0 is 0, so we end up here with 5 equals ce to the 0 power, or 5 equals c. So our equation becomes y equals 5e to the tangent x. Now let's see which solution was correct. And as you look at your solutions here, the correct answer here would have been C. So for my students, I teach AP Calculus, so if you see this type of problem as one of your multiple choice questions, you got to be able to do it. All right, so start off, if you want to, go ahead and describe your ordered pairs, get your general solution, and then go ahead and solve this. Now keep in mind now, if you're taking the AP Calculus exam, if this were a problem, one of the 6 open response questions, now you would get points for each part of the problem you could do. Even if you didn't get 5 equals C, then you could get points for separating your variables. You get points for each step in your problem that you're able to do correctly. So you'll do it as far as you can. Okay, this is problem number 2. Let's take a look at our next problem. So let me erase this. There you go. Problem number 3. All right, this is another multiple choice problem. So let's pull it up here. Let's take a look at this one now. Okay, let's see if we can figure out the correct solution. Now look how this problem is worded now. This is This is an old question. This is a question off an old AP Calculus exam again. It says at each point x, y on the curve, the slope of the curve is 3x squared y. Okay, if the curve contains the point 0, 8, then its equation is what? So they give us the 0.08. I'm going to list this up here. Now also, they don't really describe this so much as they don't describe it, dy over dx equals whatever, but they do tell us that the slope of the curve. Now slope is your derivative. So as we set this up, we're going to set up our differential equation. So in this problem, number 4, dy over dx is going to equal, okay, remember this here is going to be the slope, so it'll be 3x squared y. So we're going to see if we can describe our differential equation, right? So if 3x squared y is your slope, then slope is your derivative, and dy over dx equals 3x squared times y. Okay, now we've got our differential equation set up. Now we want to separate our variables and see if we can solve this one for y. And now take a look at our answer choices now. We got 8e to the x cubed plus 8, e to the x cubed plus 7, natural log quantity x plus 1 plus 8. So let's see which one of these here would be correct now. Now, let's see if we can separate our variables, multiply dx to both sides. Okay, we have dy equals 3x squared y. Times dx. Now we got to get rid of this y factor, so we're going to divide by y. And we have 1 over y dy equals 3x squared dx. All right. Okay, now that wasn't so bad. Pretty easy to separate our variables. All right, so for a lot of students, that's the tricky part. All right, so now we're ready to find our antiderivative on both sides. So let's integrate. This becomes natural log absolute value y equals, and the antiderivative of 3x squared would be 3x cubed over 3. Plus our constant of integration. Now the 3's cancel out. All right, and let's see, let's raise both sides to base e. So we have e, natural log absolute value y equals e to the x cubed plus our constant of integration. Now e x cubed plus c, we'll bring the c down front. So it's c times e to the x cubed power. Now on the left hand side, we'll drop the e natural log, so we just have y equals c e to the x cubed. All right. Now, this is our general solution. Let's find our particular solution. So substitute 8 in for y. So we're going to have 8 is equal to ce to the e to the x, so it'll be 0 cubed. So we have 8 equals c. So c is going to be 8. So our equation becomes y equals 8e to the x cubed power. So that should be our equation. So let's see what we have here. So it looks like the correct answer here would have been A. So that wasn't so bad, so it should have been A. Okay, so that's it. So so that's our solution. So that wasn't so bad. It's kind of tricky the way they had it worded. They don't actually give you a differential equation so much as they describe the differential equation. So that as it points to the curve of the slope of the curve. So so that's a little bit different. Okay, let's try one more problem. That's one more problem. And once again, this is going to be a multiple choice question again, so we'll see if we're able to work our next example. Actually, I believe this is example number 4. So this will be number 4. All right. Okay, let's try this one here. Now, once again, this is just an example off an old AP Calculus released problem, so off an old AP Calculus exam. Now it says if dy over dx equals 2y squared, and if y equals -1 when x equals 1. Now they're giving us a point here. So the point 1, -1. So I'm going to go ahead and list it as an ordered pair. Then when x equals 2, what does y equal? So whenever x equals 2, what does that y value have to be? All right. So let's see if we can figure out what that y value has to be whenever x equals 1. Now first we want to write our equation. Now here's what I want my students to do. Right? Let's see if you can pause the video and take you a minute or two. Let me see if you can work through this problem first. And then we'll kind of go through it and see if you were able to figure out what y is going to be whenever x is 2. Now the first point here, you're going to write your equation. Right? You're going to find your constant of integration. So this first point right here is going to give you c. Right? Then the second, then the 2 you're going to use to make your prediction. So the first one first ordered pair you're going to use to write your equation, and then we're going to use the equation to make our prediction. Right? So what is y whenever x is 2? So my students, go ahead and pause the video, and when we come back in, we're going to kind of go through it and see if you were able to work this one correctly. And here we go. Everybody should be back. So we have dy over dx is equal to 2y squared. All right, now to start off, let's see if we can write our equations. We want to find our cost of integration. Let's see if we can separate our variables first. So multiply dx to both sides. So we have dy equals 2y squared dx. All right, so now we need to get rid of this y squared on the right-hand side. So let's divide this side by y squared, divide this side by y squared. The y squareds cancel. That gives us 2 dx on the right. On the left-hand side gives us 1 over y squared dy. Now, keep in mind that 1 over y squared is actually y to the negative 2. dy equals 2 dx. All right, so now I think we've got, we pretty much have this in the right form to find our antiderivative. All right, so that wasn't too bad. Okay, I think we're ready to integrate both sides, so we're able to, we got our y factor on the left. We only have a constant. We don't have an x factor so much. We just have the 2. We're going to leave that on the right-hand side. Now let's integrate both sides. Right? On the left-hand side, adding 1 to your exponent gives me y to the negative 1 over negative 1. It's going to be equal to, the antiderivative of 2 is 2x plus c. Now let me see if I can rewrite this without that negative exponent. This becomes negative 1 over y equals 2x plus c. All right. Now let's see if we can find c first. So I'm going to go ahead and, like I said, you don't have to actually solve for c if you're just going to make a prediction here. So I'm going to see if I can get c by substituting the 1 and the negative 1 in right now. And that would give us 1 over y is negative 1. That'll be equal to 2 times 1 plus c. And that gives us 1 equals, this will be a positive 1 equals 2 plus c. So c is going to be negative 1. So as I write my equation here, this will be negative 1 over y equals 2x minus 1. So this is going to be our equation. Now I'm not going to try to solve it for y yet. I don't have to. I'm just going to use that now to make my prediction, right? So what is y when x equal 2? So let's go and substitute in, and now we'll solve for y. So by waiting, by not solving for y right now, I don't have to do this twice. So we'll go ahead and substitute in. Substituting 2 in for x will give us negative 1 over 2, or 1 over y equals 2 times 2 minus 1. Now, this was 4 minus 1 gives us 3, so we have negative 1 over y equals 3. Now we've got to get y out of the bottom of this fraction, so we have to multiply y to both sides here. And we'll end up with, let's see if I can bring this over here, negative 1 equals 3y, dividing by 3. So negative 1/3 equals y. Okay, that's what y is whenever x is 2. Y would have to be negative 1/3. And the correct answer is B, okay, negative 1/3. So hopefully you were able to work that one correctly. But you have to write your equation first in terms of x and y. We found our cost of integration. We found c. And this is just a matter of using the 2, substituting it into the equation we just wrote, right, into our particular solution now to predict what y is going to be. Y would have to be negative 1/3. Right. Now I've only done 4 examples here. These are some particular solutions, and you're just solving for c. You're finding the one curve from the family of curves. All right, so we're just finding that one curve passing through one particular point now. And I hope you've found these 4 examples helpful. If you've not seen my first video, go ahead and take a look at my first video. We have about 10 examples of just separating the variables and solving and getting some general solutions. So a lot more examples on my first video. You can take a look at that. But hopefully you've found these helpful. So I think we're ready to do our homework now.